Hi,
Hi, good morning.
good morning. Wait for I have to change my name first.
Yeah, sure.
Yep. And say this one to the back of the screen. Hi, so we are waiting for the participant.
Participant, yeah, because the start with the 10 o'clock.
Oh yes. So did you have breakfast already?
Yeah.
Where are you from actually?
I'm from Bangladesh.
I see.
I think I have to Windows sunlight.
Oh yes. Oh, you look brighter.
Yeah.
Um, my one is brighter because I put the tree light in front of me.
Yeah, it's okay. It's nice backgrounds for yours.
Oh yeah, because last semester we have in the online class, so I have a light in front of me
Ah, okay.
and with the background, so that's why you will see the difference. Yes. So waiting for them. Okay. Bring the title back to there, so I can look at the title. We have fighters. I can see all the titles together. Okay. So I have double monitor, so I put the title of the today presentations list at the back of the other one screen.
Yeah,
So,
me too. Also, same. I also the same.
oh yeah, because I connecting a notebook with a monitor together. Oh yeah. I didn't use earphone and mic because I have the separate mic and camera.
Yeah, your voice is really good. Shizuke, no need to that.
Oh, yeah. I hope that yeah they also have the same thing as we do.
Yeah.
Mm. Mhm. Yeah, yeah. You don't know. Is that the presenter will come in one by one, or they can come in together or
All
join?
all they, we have a given invitations, so they can come on the times or before it also. They can join the whole session.
I see. So you keep in touch with them now, or
Yeah,
how?
yeah, yeah. So
I
our other
insist.
team members also, they are keep in touch with them, and also we have a given send the email, they
I
confirm
see.
it.
No even co-chair in my sessions. Okay.
There is a co. Okay, so there is a option will be the, there
This
is a,
of
but name is not displayed. You can write it in rename in before your name, the co-chairs.
oh yeah, you want me to write that, right?
Yeah. So already you are the co-host. We have mentioned it here.
Oh yeah. Okay. I write down the same way as you do. I think it's better.
Yeah. Good morning, Neeraj Kumar.
Hi.
Hello.
Let me see. Does she turn on the mic, everything or
The
not?
presenter ID. Oh, he left.
Oh yeah. I think she will start again, coming in again. Well, this Zoom is that connected with the live or the YouTube?
Yeah, live. Yeah, live is streaming. Okay, I sent to you the link to you. So okay, in the chat. So if you can watch is here in this link.
Yes. Ah, so I have opened another one to the other side. Put it
So we share the screen.
I I see they're both side.
Yeah, it's maybe 5 second delay to streaming.
Oh yeah, it's delay. That's true. You see the reactions. Okay, okay, I better turn off because they're double sound on my side.
Yeah, you can the live one you can watch or that mute the speaker.
I see.
So now I'm sharing our banner, the
Oh yeah,
poster. Now it's come, right?
yeah. I think she tried to come in again. He or she, I think.
The he is Neeraj Kumar. He's from
Okay.
India.
Oh, when I see the chair today, I will see like uh the chairman. Some of them from Vietnam, and
Uh,
yeah, I see the name with the Vietnamese name. The doctors. And for India, is there somebody from Pakistan too?
I don't think so.
Okay. Mm. Dr. Grace Kennedy is from where?
She's from Nigeria.
I see. So that means in this whole conference, there is no Korean presenters, right? When I see the name list, yes.
uh, yeah, the our session no.
Yeah, I didn't see the Korean presenter with the Korean name. So when I see all the list, I will see, oh, yeah, he's coming, I think. No. Hi.
Hi.
I
Guys,
see,
am I audible?
I see it's on the mic already.
Uh, Hello.
Guys, am I
Hi.
audible?
Uh, can you share with your video and can you rename your the name as a uh, presenter 28?
Do I need to share my video as well?
Yeah, because conference it is the live telecasting, so it will be more better to if you share.
Actually, I've joined using a desktop. I do not have a webcam on this.
Without cameras. I see.
Okay. So then you can change your the name to so we sequentially we can follow the rename the your name. Just right click on the your triple dot and there you can option
Sure,
rename just the presenter 28.
sure. I'll do that right away.
Okay.
Yeah, thank you.
Are we waiting for someone to join as well?
No, actually, our session will be start in the 10 o'clock, so we follow the timing actually. So if there is during the sessions timing, so somebody to come, so we can make.
Sure, sure. I'll just mute myself for that period.
Does he can see us? Because he
Uh,
doesn't have the camera.
She can. I think we can see. Okay, let we start. Welcome to the first international conference. The conference name is Smart Cyber 2020. So the organizing the department of the smart computing, the Kyangdong University is the very famous place. It was is the we actually we planned it is the physical, but COVID-19 due to the reasons, so we are going for the online the conference. It's really beautiful place of the in South Korea. I have been visited many places, but I have feel is still is good place to is like conduct a international conference. So let me introduce myself. In the session chairs, I'm Dr. Noor Alam, the professors of the smart computing, and here with is the co-chairs with the professors, the Kun Lee Hugh. He can introduce. She can introduce with himself. Okay, can you introduce yourself?
Yes, I'm Dr. Kweli Hui. So I'm in the electrical department in Dong'an University.
Okay, so let me we present in the first uh, presentations. So the paper ID, the 28, the customer uh, sentiments analysis use the cloud apps and the machine learning model. There is a author's name is the presenter. Can you hear me?
yes, yes. Hi,
Yeah.
very good
Okay.
morning.
Okay. Then you can start your presentation, please.
Sure. Can you please enable host sharing so that
Okay.
I
Yeah. Yeah. Is host sharing. You can try. Then
it's saying that host has disabled participant
okay.
sharing.
So okay. Wait a minute. So make allow to. Now you can share your.
Sure, I'll try again.
Mhm.
Please let me know once you're able to see my screen.
Yes. Okay.
Okay, guys, very good morning to everyone. My name is Neesh Kumar. I'm a cloud implementation specialist. I've also been a trainer since 2015. I'm basically expert on Azure. I've also done AWS certifications as well. So today's presentation, this is the entire agenda that I'll be sharing with you all. First, we'll introduce the topic that I worked on. We'll understand the software requirement specification. There will be some literature survey, a detailed design of my project, existing and proposed system. We'll see what are the differences between both of them. We'll see the module implementation. We'll discuss the results, and finally we'll conclude and see what we can do in the future on this project. So as you are aware that customer sentiments are very important for any business, as positive or negative feedback can affect the sales and adoption of a product in the market. So if you have a positive feedback, the company can grow exponentially. And if you have a negative feedback on a product, the company can just drop that product and work on some other product, which will basically help them succeed. So I've chosen Twitter as my medium to basically, just give me a second, guys. Let me pull up the pointer. So I'm using Twitter as my social media platform to do this customer sentiment analysis. So as you can see, Facebook has around 2.32 billion monthly active users, and Twitter has around 126 million active users. So hence these are very big markets in order for us to do a customer sentiment analysis. So if a product is successful in any of these social media, it is guaranteed that it will be successful in larger market as well. So the essence of the approach that I took for this project is basically I used a Logic app and connected it with Twitter. And from Twitter, whatever tweets anyone posts, we'll be getting data in our SQL table. And that SQL table is connected to a web app, which is going to transfer all of the comments to a cognitive service. And this cognitive service is going to give us a score from 0 to 1. So 0 means it is a negative sentiment, and if the score is towards 1, that means it is a positive sentiment. So in my specific project, I have used iPhone as a parameter. So if anyone types hashtag iPhone, we are going to get sentiment on the comments anyone types after that hashtag. So this capability is useful for detecting positive and negative sentiments in social media, such as Facebook, Twitter, customer reviews, and discussion forum. So the beauty of this project is we can use the same technology to basically gather reviews or gather feedback from any of these platforms, be it social media or any other platform. We just have to populate our SQL table. Once it is populated, we'll be able to gather the feedback on the same. So the machine learning model used by cognitive services help determine sentiment using data provided by the user. So if someone tweets a positive sentiment, we are going to get a score which is towards 1. So it can be 0.098, 0.98, or if it is a negative sentiment, we are going to get a score which is towards 0. So that is how we can determine the sentiment of different users online. So I've used Microsoft Azure as my platform to showcase this project, because Microsoft Azure provides me all the infra that I require. So I don't have to build all the infra on my local machine. So I'm going to leverage the services from Azure to basically deploy this entire project. So in order to meet the software requirement specification, so for example, there is a business requirement to pull tweets from Twitter. So in order to accomplish that, I've used Logic app. So it is a workflow kind of a service, which is going to pull all the tweets from Twitter. If I want to store data, I've used SQL database. So this is another service from Azure. So we'll create a new table, and that table is going to help us to store all the data in that table. After that, I have to analyze the sentiment. In order for me to analyze the sentiment, I've used Cognitive Services API, which is basically doing a text analytics. So it is going to determine the text and find out if it is a positive sentiment or is it a negative sentiment. In order for me to report all the findings, I've used Power BI. This is a separate service from Office 365, which will give us intelligent reports on the same. So these are some of the business requirements, and I met these functional solutions by using Azure services. So software and hardware requirements, we do not need a very heavy machine because we are using cloud. So basically this can be a local machine, and all the services that we require are deployed in Azure. So Logic app is used for workflows. Web app is used to basically connect your SQL database to your cognitive service. SQL database is basically used to store all the data that we are going to gather. Cognitive Services API is going to provide us the score. It is going to provide us the ML model. If you don't want to use cognitive service, we can also leverage machine learning model, or there is a service called ML Studio. ML Studio from Microsoft. So this service, we can create our own machine learning models as well using this service. We also have to use Power BI. This is basically you have to purchase licenses for this in order for you to get business intelligence report. Although you can also use free trial. So all of the things that I want to accomplish, I have accomplished on the cloud, even in a free trial. So I don't have to purchase anything in order for me to show this entire working of this project. So literature survey. So I also did some research on different projects which are already available. Fang and Justin Jan did a research on sentiment analysis using Amazon product reviews. So basically, they categorized all the product sentiments and polarity categorization using polarity categorization process. Also, they did a sentence level categorization of Amazon products. So they basically gather all the data. Is it a positive sentiment? Is it a negative sentiment? By using machine learning models, they were able to categorize different sentiments. Also, I referred another paper in which Shahid Shah et al. Basically did a sentiment analysis on big data models, application and open challenges using Twitter. So basically in this paper, they showcase that Twitter is the best medium to perform big data analytics because it was statistically proven to be more efficient in detecting correct sentiment. So basically, they in this paper, they came to a conclusion that Twitter will be the best place to do a sentiment analysis because it has some character limit, right? So you can have these many characters that you can type in Twitter. So that is why it is easier to do a sentiment analysis because of the conciseness of Twitter. So that is why I also chose Twitter as my medium to do the sentiment analysis. Existing system basically is referred, this Xinfang and Justin Zhang system was referred to do this study. So some of the drawbacks that we can have of this system is it is great to capture the product reviews on Amazon, but can fail if working with other platforms. So it works great with Amazon, but it might fail with other platforms. Whereas the system that we are designing can work on multiple platforms. Fake reviews and spammers can skew and affect the correct results. So if some company has paid some bots, they can basically skew the results as well. The existing infrastructure allows people to post their opinions, and honesty of opinion cannot be guaranteed. So you cannot guarantee if someone is providing you a correct feedback or not. Some people might just provide you fake reviews. So that is a problem in an existing system. Fraudulent opinions with spams that do not relate with the product can be posted. So maybe they might post some comments, which is very difficult for the ML machine learning model to detect. So those can be another issue that we can face. Sarcasm can lead to cognitive service not determining correct outcome of the sentiment. So sarcasm is very difficult for the machine learning model to detect. So that can also skew our results. So these are some of the drawbacks of the existing system. So this is our proposed design. Okay. So basically, anyone tweets anything about iPhone. Okay. So I've used iPhone in this, but besides iPhone, you can use any other thing. For example, you can do a comparison between different political parties. You can do comparison between two different products. So anything you can take to basically get sentiment out of. So I've used iPhone in this. So if anyone tweets hashtag iPhone on Twitter, a connector from Logic app. So this is a Logic app. A connector from Twitter is going to basically gather that feedback or comments. This is then going to be connected to a SQL database. So there are two connectors. One connector is basically fetching all the tweets from Twitter using Logic app, and another connector is basically storing all the data that we have collected in a SQL database. So all of these services are provided in Azure. So I don't have to deploy anything. So in this, we have created a table. Okay. So this table is going to get populated. So we have different columns available to us, different rows available to us. Whatever anyone tweets is going to be populated in a row, and all the columns will be filled as well accordingly. So as this table is populated, we have also created a web app. What this web app is going to do, this web app is going to have a connection with this table and also have a connection with a service called Cognitive Services API. So it uses text analytics. It uses text analytics, and it is using the data of Microsoft. Okay. So Microsoft data center will have all the data, which is basically helping the ML model to train itself. So if our ML model is trained, all the data, the machine learning model already has a lot of data to work with. So this web app is going to fetch all the data from this table and there is a score column over here. Okay, so this score column is not populated. This is null when we start, but as soon as this data is fetched in this cognitive service API, this cognitive service is going to provide us a score between 0 or 1. So if it is towards 1, this means this product has a positive sentiment. If it is towards 0, that means it is a negative sentiment. And if it is 0.5, that means it is a neutral sentiment for that product. So once we capture this sentiment, this cognitive service is going to populate the score column in this table. Once this score column is populated, we are going to get a Power BI report. So we have also integrated the SQL database with this Power BI. This Power BI is going to give us a very beautiful, intelligent report on our screen. So we can basically find out various things using this Power BI. We can also create queries to find out different things about that product. Okay, so not just iPhone, we can use any product over here, and Twitter is a good medium to get these feedbacks. So this is our entire architecture that we are going to be using. So some of the things that I've already explained in the earlier design are mentioned over here. Tweets from different locations posted by different users on Twitter are populated, pulled using Logic app using the Twitter connector. So we have created a Twitter account and we have used a Twitter connector to connect to that account using Logic app. This connector performs the workflow integration. So Logic app is a workflow application that we use. Okay, of connecting to SQL database, the data is inserted into the table, populating different columns and rows except the score column. So only the score column is not populated. Rest all other columns are populated. The web app combines the connection between database and cognitive service to fill the score column. So basically this web app is going to get the connection string from database, and it is going to provide a connection to the
Uh,
cognitive.
Please, can you fast your presentations because the almost 15 minutes you occupied. So,
Sure. So
okay.
I'll just skip the again whatever I've discussed in the architecture over here. So let's skip this. So this is the entire workflow. So any person tweets anything on Twitter, they're going to get connected to Logic app, and cognitive service is going to provide us a score, and that is going to be populated in Power BI dashboard. Okay. So this is the design of a web app in Azure. So I'm not going to explain this, just to speed up the process. This is the data flow diagram. A tweet is posted, Logic app is going to connect it. SQL data is going, base is going to store all the tweet in the table. Cognitive service is going to provide us a score, and Power BI, we are able to see that score over here. So this is how you can create a table in SQL database. This is where you are going to provide the connection strings. So you are going to provide database string and all those things. And this is going to basically provide you a connection between cognitive service as well as SQL database. So I'll just skip this part. I'll just directly go to the conclusion part. So basically, again, we are getting this score, and what we can do in future, I'll just skip to this part. Tackling fake reviews and opinions by tagging each tweet or comment with correct training model will ensure only relevant training data is captured. This application can be used to capture sentiment on other social media as well. In future, what we can do, we can also train our ML Studio to basically understand sarcasm. So in future, if I work on this project even more, I can basically allow this to understand sarcasm and make this project even more successful. So once you're done with the entire thing, you will be able to see these reports. You can create maps throughout the world, and you can see sentiment throughout the world if this product is liked or not. Okay, so this is how you can also publish in Office 365 and share it with others. So this is the entire thing that I wanted to discuss. So you can ask any questions if you have.
Okay, first of all, thank you for your nice, wonderful presentations. So, I have one question. First, I ask you, then I have another co-chair. She will also may ask you the questions. So you have mentioned in your paper the is machine learning model. Is there any specific the algorithm did you apply for these applications? Or algorithm applied, or the just you have to the use only the Microsoft the features functions you use?
Actually, Microsoft provides you a built-in ML model which uses text analytics API. So similar thing you can use in ML Studio as well. over there you can create your own models. So I've used Microsoft algorithm. I haven't applied any new algorithm from my end, but you can do that using ML Studio. It is a service from Azure, which you can basically create same kind of model using that service as well.
Okay, so Professor, if you have a questions, then ask him.
May I ask one question? So you said that just now, like let's say the the previous researcher they're doing that they can apply to the Amazon platform, and they
Yes.
cannot like it not working well with other platform. So how about yours one? Can you apply to any platform you can apply?
Yes, so basically you need to populate the SQL table. So if you are able to get the data into the SQL table, you will be able to use any platform. So you can use discussion forum, you can use any text-based platform, and we can get a sentiment out of it. So we always prefer smaller sentences so that model is able to easily and quickly detect the sentiment, but larger sentences will also work. So, but we prefer to add a smaller comments. So if you have any platform and have smaller comments, that will easily help us detecting the sentiment. So we can leverage any platform.
So is that the platform only apply for the English platform instead of other language, right?
As of now, I have worked on English language, but in the future, we can work on other languages as well. So I've only understood about the English language as of now, but later on, in future, we can work on other languages as well.
Yes. Thank you so much.
Okay,
Any
thank you for the presenter, the 28th and the Neeraj. So we have to, you can stay with our presentation session. So now we go back to our second presenters.
Thank you. Have a good day, guys.
Yeah, thank you. So the presenter, the 31, the paper ID is the model enhance based and the facial expression using the machine learning and the virtual assistant technology in Android apps. So can you hear the uh, presenter 31? Hello, I think she will, or he will.
I think maybe the network is not that stable for her. I
Uh-huh,
think she will coming back again.
yeah. So we can go for the next presenter. Or
Oh
we
yeah,
can wait 1 minute. I think it's better, right?
yeah,
It
I
may
think so.
be.
I think yes, coming. Somebody's coming
Yeah,
in again.
yeah.
Hi.
Hello.
Hello.
The those who are the presenter, please to make sure that you rename with the presenter ID.
I think for the presenters, can you turn on their webcam if you have webcam?
So, Philip Louis, you are a presenter. Which number you have? The paper ID. Hello.
He didn't turn on the mic. Therefore,
Yeah. We can ask him to the.
I think he tried to work out now.
Uh, Arvind Kumar, can you please rename your presenter ID, please? You can see your name. There is a 3 dot. The select that one. There is an option rename. So you can rename the presenter ID, please. Can you hear the Arvind Kumar? Hello.
Yeah, he turned
Yes,
on.
sir.
Okay, so can you please you rename the presenter ID, please?
Sir, presenter is my student. He is in online only.
Okay, so what is the paper ID, sir? Your
Paper ID is 28.
48.
No, 28.
Oh,
28.
oh, okay, okay. So already is done. Okay, so 28 is done. So I think we have to go waiting for that. The second papers.
Yeah.
So it is the. Sir, can you know your same institute, maybe in the SRM University, the Manjula P and the Akshay
Yes.
Nakpal?
31. 31. Paper ID 31, right?
Yeah, paper ID is 31 exactly. So
Few
is
minutes.
there? Okay,
I'll
okay,
log
sure.
off. She will log in.
Okay,
When I
okay,
log
sure.
off, then only she will log in.
Yeah, okay, 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 sure, sure.
Few
Okay,
minutes. Few minutes, sir.
okay, okay, okay. Thank you, sir. Okay, the presenter ID 42. Can you turn on the video camera? Are you here, the presenter 42?
Maybe he's not there first. Presenter 42, are you there?
Uh, where are you? Mm.
Hi.
Hi. Okay, so can you possible to the only turn on your video? I think she will come, right? Manjula P is here.
Hello, sir.
Hello, sir. Uh,
Sir, Manjula P is ready, but we
okay.
need 10 minutes time, sir. We need 10
Okay.
minutes time.
Okay. So
Due to
I hope.
some
I think, okay, so it will be, maybe we have to switch. We have a, let's check with the
Yes, you can
presenter
give the
42.
chance to presenter 42.
Yeah, okay.
We will back,
So,
sir.
okay.
Within 10
So,
minutes, we
okay.
will back.
So 42 paper ID. Shahi, are you here? Shahi, can you hear me? Shahi, presenter ID 42. Are you here? To,
Yes, I'm logging, Professor.
okay.
One second.
Okay, okay, log in.
Hello, Philip Luis. Mhm.
Okay, so
Hi. Hi.
Good morning.
Morning. The third, you turn on, you turn on your mic. Can you turn on the mic?
Yes.
Okay. I interrupt you. So you are the presenter 43.
Yes.
Can we start with the presenter 43?
Thank you. I'd like to share my screen first.
Okay.
It's getting an alert message. Host disable participant screen sharing.
Can you tell us the title again?
The title for my presentation is Apple Defect Detection based on Deep Convolutional Neural Network.
Okay. So we start with the presenter 43. Yeah, you can share your screen with us.
I'm not able to do it now.
Oh,
It's still disabled. Yeah, I can do that now. Thank you.
welcome.
Good morning, everyone. Respected panel chairs, I'm Soga Sai from Kyongdong University, a presenter and author for the paper named as Apple Defect Detection based on Deep Convolutional Neural Network. So I'd like to go through my content I'll be presenting today. That is the introduction, the related work with this article, the data collection process, classification of network architectures, the construction of the classifier, and the selection of the project regions, and going through the results, as well as finally concluding it with the future works. So let me get in through the introduction. Here, as our title depicts, we have two categories of an apple. That is the normal skin and the defected skin. Normal skin means a clean apple or a plain surface, where the defected area means we have sought out the defected means scab, bruise, crack, cut, or the defect with the stem and calyx of the apple fruits. We have proposed a convolutional neural network. It is a class of deep neural network which is most commonly applied to analyze visual imagery. In this preparation of a CNN architecture model, the parameter initialization accelerates the network training process. The main focus or the main goal of this paper is to develop a vision-based classification and detection system to distinguish apple fruits and defects using deep convolutional neural network. The system is based on convolutional neural network followed by the selection of the proposed regions. Here the proposed regions is also the region of the interest, where the training of the classifier is performed with the data set derived from the set of images taken from the agricultural based industrial food sorting process. So I would like to present some of the related work using the deep convolutional neural network techniques. Here are some of the network techniques like AlexNet, GoogleNet, the visual geometric group, and I have depicted two examples using the deep learning techniques or using these networks. Here the Mohanty used AlexNet and GoogleNet and some other deep learning techniques to classify the 26 plant diseases where the accuracy was about 99.35%. Similarly, the Ferranti notes compare the classification performance of 5 deep learning methods using the such networks on 58 different plant diseases, and the highest accuracy was recorded 99.53%. In the recent scenarios in the agricultural field, deep learning techniques has been widely applied in crop detection and classifications, as well as the pest and the disease identification and diagnosis. Now, I'd like to show you my data sample. It is the normal skin apple sample, which you can see it is a plain and a clean normal apples. So on the basis of visual inspections, we classified normal skin, and on similarly with the visual imagery, we created the data set as a defected skin samples. You can see on the image that there are several defects, as we mentioned earlier, the defects like scab, bruise, or cuts. So this is our data set that we created or we constructed for this classification. The data collection process, as mentioned earlier, we collected these samples from the Rural Development Administration from the Republic of Korea. The red delicious apples were classified as the normal skin samples and the defect apple samples to develop the algorithm. I already mentioned about the normal skin samples and defect samples according to their characteristics. Now they are fed into the neural network for the purpose of training. So this is the main method, or this is the network architecture we created for our classification of data set. Here we have the original image size 502 by 300. Image is nothing, just the matrix of pixel value. So we have created here two layers. The layer in the green depicts the feature learning, and the layer in the brown depicts the classifier. Within the feature learning, we have here multi-level perceptron, including the convolutional and the pooling layer, which is forwarded by the patch value. Patch is the subsection of an image. And here we have used the dropout techniques to reduce the computational complexity. Forwarded, the capture images are cropped 64 by 64 size. That means it is passed by the visual inspections to produce a new image. These input images are labeled as positive samples and negative samples as per the presence of defects and absence of defects. The data considers in the same area and yielded 7,200 total samples containing 3,600 positive and 3,600 negative samples. And we use 80% of the positive samples for the training and the remaining 20% is used for testing the model. Forwarded on the network architecture, I mentioned earlier, we have the multi-level perceptron of convolutional and pooling layers used for the proposed architecture. The convolutional layer is used to set the trainable models in implementing complex nonlinear functions to find out the hidden patterns in the on-level data. And the pooling layer is utilized to downsample the feature maps and the filters done as an operation into regions and collects the statics from each region. Here, as I mentioned earlier, convolutional layer implements nonlinear function. For implementing nonlinear function, we implemented an activation type of ReLU. ReLU stands for rectified linear unit, which consists of 20 filters of 3x3 dimension. So this is the arrangement for my architecture. That is, we use the convolutional layer, and we have the maximum pooling, which is activated by functions ReLU. And in the classification area, we have used a cost function, that is softmax, which is used to estimate the probability of the predicted class. Now we have gone through the classification of our dataset, constructions of the architecture. Now we have to localize it with the testing dataset. So we created this algorithm to classify or the test between the outtrained and the tested modules. Here we send the input images, that is also known as the testing images, through the sliding window where we get an output in a binary format. The framework in the figure receives an image of the size 502 by 200. Then it is resized to reduce the computational complexity. The patch images are fetched into the classifier network, where the same arrangement as convolutional, activation, and pooling yields the 50 features representing the input patch. The features are provided into the neural network to yield the probability for both the presence or absence of defect. If the probability for presence of defect is more than 99%, then the output is considered as 1 and 0, because the output for this region is depicted on the binary format. Now I would like to explain the experimental results. Here we have set out the 4 conditions, that is the true positive, true negative, false positive, and false negative. So we did this for both the normal skin and the defected skin. We calculated the precision value, recall value, and the F1 score for both of the classes on the best of the conditions. So it depicted an average of around 95 to 97% for 4,000 epochs, thus reaching the accuracy of 96%. The result of our experiment shows an accuracy of 96% overall defect detection rate using the independent samples that we collected with different defect skin conditions, which indicated that the proposed defect detection CNN algorithm was effective in the differentiation of normal and defect samples. The features were fed into a neural network with 128 neurons, and the output probabilities resulted in a binary map. The formulated architecture can be viewed as a light neural network, and hence it is memory efficient. The performance and flexibility of CNN reveals a clear improvement over a classic machine learning techniques. So some of the future works that can be forward implemented through this article is, as we accumulate the accuracy of 96%, we can forward improve the accuracy of our algorithm. The application of this algorithm can be done to other food processing or other feature abstractions. And as we conducted this experiment on the basis of the data collected and stored in a ORCAD or some place, so the future work, one of the future work could be to achieve the real-time image processing. So this is all about my paper and my presentation. So if you have any concerns regarding my paper and my presentation, I'd love to answer it.
Okay, I have one question with that. Can I look back to your slides for the first two slides? So you say the normal and defect one, the defect one can divide it to now, like you look at here, right? 1, 2, 3, 4, 5, 6, 6 different type of the defections. But when you look at the results at the last part, 96%, can you going down to the last slide?
Yes.
Yeah, you see the defect here is like coming out with a 96%, 95%. It's a defect. You can categorize it into like the 6 categories that you have just now for the defect and normal one.
I already mentioned that we have set out the 4 conditions for each category, whether it is the normal skin or the defected skin, on the basis of the true positive samples or the true negative samples. We have set out the 4 conditions. On that basis, we calculated the precision, recall, and the another one, the F1 score for both skin, whether it is the normal one or the defected one. The defected one is calculated on the basis of the sorts of defect, the 6 categories we have set out, and the overall precision and the recall values were calculated, not for the individual basis, but for the defected skin that were sorted out or that were depicted as an output, because we set out the 4 conditions, and on that basis we categorize the defected skins.
I see. So this means the defective skin is not categorized according to the 6 stage, but according to normal skin and defect skin, right?
No, the classifier classifies based on the characteristics of the defected samples. We have already set out the categories for the defected, but the accuracy or the average of the defected samples based on the conditions we set out for those categories.
I see.
So I think is your answer is not the appropriate. Actually, the professor asking to you, the basically I know this paper. So there is a 2 class, no the subclass categorize. So defect on the normal. So no more the inside the classes to the defected one.
Oh yeah, yeah. This is what the one I want to know.
Yeah, yeah. Okay. So anyone to ask 2 questions? Okay, so I think thank you very much for the presenter 43. So I hope you can face in futures in the more when you have attend the conference in the similar type of questions. So you be prepared. Okay, thank you very much.
Thank you.
Oh yeah, you can stay with us for the rest of the presentations.
Yeah, you can stay.
Sure.
Yeah. So we go for just now. We have the presenter 31, I think.
Josna, yeah, she's
Ready
coming.
for the
Okay.
presentations. Yes.
Yes, ma'am. Good morning, ma'am.
Yeah, you
Good
can
morning,
start
sir.
your yeah. Good morning.
Can you turn on the video or how? Or you're going
Okay,
to
I have to make it. Okay, so I give the permissions to you. You can share with your screen and you can turn on the video camera, please. So it will be the more better because we are doing in the online streaming, live streaming. All participants can allow the video also. The turn on your video camera.
Sir, is it audible? Sir, my slide is visible. So my title is Mood Enhanced based on facial expression using machine learning and virtual assistant technology. It's an Android application.
Can you check the microphone, please? There is a little bit is the noisy.
Now it's okay, sir. Now mic is okay, sir.
Yeah, it's okay.
Introduction. Facial expressions are very important in human communication and interaction. It allows us to express our views to others. There are different types of emotions are available: joy, sadness, and anger. By using this facial expression, we can express our communication to others, and also we can use vocal tone to express our views to others. There are two types of communications are possible: verbal and non-verbal components. Verbal components, it conveys 1/3 of human communication, and non-verbal components conveys 2/3 of communication. So in the facial expression, we are concentrating only on non-verbal communication. And also, it is natural that research of facial emotion has been gaining a lot of attention over the past decade. Objective: to enhance the user's mood by classify facial expression using machine learning algorithm. Existing system. Some of the existing systems available in the market are Apple 3, Microsoft Cortana. Apple 3, it is used in iPhone. Then also the domain of face recognition is gaining face and can now be easily seen as essential feature in smartphone devices. Many multinational companies like Google are spending good portion of their annual budget to better understand the concept of human facial expression recognition. So due to its potential, the domain of facial expression recognition is gaining boom in the market. However, it is still an area of research before successful. Proposed system. Our system name is Mood Enhancer application. It is unique blend of two concepts: facial expression recognition system and virtual assisted technology. At first, we'll take the human faces input, and then system will detect and predict the respective facial expression. Finally, upon the prediction, it will present the user with dynamic responses to enlighten the mood. Steps for recognizing emotions. First, we will give the input image to face detection. First, we'll get the input image for face detection. Then, from the image, features are extracted. Based on features, we'll classify the image whether they are in happy mood or sad mood or angry mood. Likewise, we will get the output for emotion. Next, module 1, feature extraction. There are two types of parameters are extracted from facial images. First one is real value parameters. Second one is binary parameters. Real value parameters are eyebrow rise distance, upper eyelid to eyebrow distance, inter eyebrow distance, then upper eyelid to lower eyelid distance, then top lip thickness, mouth width, lower lip thickness, mouth opening. Then binary parameters are upper teeth visible, lower teeth visible, forehead lines, eyebrow lines, nose lines, chin lines, and nasolabial lines. Second module is classification. By default, our Android application uses CNN model, convolution neural network model. And also, user can choose other three models such as Navy-based model, logistic regression model, SGD model, stochastic gradient descent model. And also, in the Android application, we are using some additional libraries such as TensorFlow-like, glib, OpenCV library, and VCA library. This is the data flow diagram which indicates basic overview of emotion classification. User gives an input image to facial expression recognition algorithm. So the output will get us emotion classification. So the output should be responded to the user. Implementation of system or methodology. First one is splash screen. So this is a welcome screen. It is also known as splash screen. It's a first and foremost screen visible to the user. It presents our brand logo as well as graphics depicting the main idea of the application, that is moods. Then home screen, it will be the layout which hold all the available functionalities of the application. Here we are using camera screen, camera for the face of the user. Here we are using gallery option. User can select the image from gallery. Then toolbar and its menu option. So toolbar is the topmost rectangular pan which holds the application logo, then application title along with some menu options. Here we are having three options. Select default model. So CNN model will classify the image. Other models in the sense navy based statistic regression and another one model is used for classify the mood of that person. Then camera screen. So it's a camera screen. In the home screen, we are having a floating button, that is the elegant camera icon, which tells the user to launch the camera screen and start checking the mood through live camera stream. Gallery section screen. Here user can select the photo from device default gallery and run the emotion detection algorithm over it. And final one is conclusion and future work. So the complete journey of developing the entire project has been fascinating, and also it provided a new learning opportunities as well as tremendous brainstorming checkpoints. But future workers, we can add some additional features like happiness meter, how much percentage they are happy. So that is added in future, and also we can make the application more appealing and interactive by add some of the functionalities of text to speech into the response of the application. Thank you.
Okay. Thank you for your presentations. So can you go please with your slide?
Thanks.
So you have mentioned the extract from the second image, the facial, the emotions, right? So what are the parameter you are using for that detections for the emotions, the humans or pictures? Go back. Next. Next. For the specifically the what are the facial emotion parameter you using here?
Sir, can you tell me again, sir?
Yeah, sure. So you have the features extract for the facial, the expressions, right? So that expression, what are the parameter do you use
Yes,
in
sir.
technique?
Binary parameters, real valued parameters we are using. Binary parameters, it indicates zeros and ones. If the teeth is visible, it considers as one. Otherwise, it will be considered zero, sir.
Is there any pause related
Likewise,
using any pause in your face to the estimated for the facial expression changing?
any part.
Okay, so I think professors have questions. Do you have any questions?
I think I have the same question as you do. I also curious with the classifications because you're going to express sadness, smile, everything, but you see the primary parameters and the real parameters, they have so many parameters from here. And through the parameters, how can it show like happy, sad, or not that sad? So I can't see the classification from here. That's why I have the same question as you do.
Okay, I think thank you for. Do you have any answers for this?
No,
Just
sir.
now? Okay. So I hope you can improve in the futures. Thank you very much your presentations, and you can continue with us as a participants. Okay. So our session will be not finished yet.
Thank you, sir.
Mm.
You're welcome.
Thank you.
So just now we can make it in the withdraw the co-host. Okay. So now the presenter 42. Can you hear me?
Yes, Professor, yes.
Okay. So can you turn on your video?
Yes. Good
So
morning, Professor.
okay. Good morning. So 42. So I allowed to you make a you host to can you share with your can you start your presentations now? The
Hello, everyone, and thank you so much for having me. It's me, Rakesh Thapamagar, the author and the presenter of this paper. And the title of my paper is Apple Defect Detection Based on Average PC Using Hyperspectral Image. And these are the content which I'm going to cover on this PPT. Introduction as a sample about SIS, information data sets, algorithm, PCA, select PC, results, conclusion, and future work. So let's hear it step by step. Talking about the introductions, skin defect detections of apple fruit is the main problem of this industry. Indeed, apple is a very common fruit, but also the people are selling and buying the defected apples. Apple industry requires an automatic apple defect detections to decrease production cost. In this study, the detection method for skin defects is the red deletion apple with the hyperspectral imaging is represented. The goal of hyperspectral image is to obtain the spectrum from each pixel in the image of a scene. Human eyes can see a visible colors of 3 bands, RGB, as you know, red, green, and blue. But the spectral imaging device is spectral into many more bands. The goal of hyperspectral image is to obtain the spectrum from each image in the scene. The method has been devised to process from the 403 nanometer to 998 nanometer with the 125 subsets. The purpose of this method is to detect the following apple skin defects: scrap, bruise, cracks, and the cuts. The hyperspectral image represent the same object with the different wavebands, so it provides an evidence of the spectral data for statistical feature analysis in image processing. Establishing the average principal components to detect various skin defects helps Apple surface in full. We propose a new algorithm in this paper for detection of defects through a simple average principles component without Apple image orientations and the Apple orientation and the segmentations. Finally, to develop a system, we classify good or bad apples based on HSI, which is hyperspectral image. Okay, this is the sample number 9. We have taken a total of 350 samples to develop this algorithm, but this is the sample number 9 of hyperspectral image. This apple is defective. As you can see, a black hole in the middle of the apple. This is also known as a scab. The next slide shows the 125 wavebands. Images range from 403 nanometer to 990 nanometer in 4.8 nanometer intervals. The intervals of 1 and 2 is 402 nanometer. 4.8 nanometer. The first one started from 403 nanometer. Then the second one started from the 403 plus 408 nanometer. By this, it all ends up to 125 subsets. 125 subset up to 998 nanometers. And these are the HSI information which we have been using for the hyperspectral image acquisitions. The apples were dumped at the loading end, and the apples randomly moved with the conveyor belt as they were built by the overhead camera. To obtain more accurate data, the sum of the parameters were adjusted before the image were acquired. The conveyor belt moved the apples across the FOV. field of view of the camera at the approximately 4 apples per second. The distance between the camera lens and the object viewpoint were apparently acted at a 45 cm. A light from a pair of 150 watt quartz tungsten halogen lamps were used at the lighting angle is approximately 45 degrees. The line by line scan data were saved in image file that includes the spectral data along one axis and spatial data along with other axis. The Ixon DU860 electron multiplying charge coupled device camera with 1.4 focal length and 35 nanometer lens were used for the hyperspectral image. The spectrum for each pixels span the range from 403 nanometer to 900 nanometer, as I have already mentioned, and the pixel resolution of each nanometer is 502 into 200, and the data type is 2 bytes. And these are the data sets which we have used with the different skin types. Talking about the data sets, a total of 350 red delicious apples were used to develop the algorithm. 40 were normal skin, whereas 310 were defected one. The 350 samples were separated into normal and defect apples using a visual inspection. Also, the normal defected apples were also sub-categorized into scab, bruise, crack, cut, steam in, and cracks as shown in the figure. A represent the scab, B represent the bruise, C represent the cracks, and respectively. And this is the proposed method of our paper. The basic algorithm of the proposed method can be subdivided into these figure steps, as you can see in my screen. The hyperspectral image data analysis and principal component analysis is done using the MATLAB 2019A, and the hyperspectral image needs to be corrected with white and dark reference. The original hyperspectral image HSI0 represented by HSI0 should be corrected based on dark hyperspectral image SID and the white reference images HSIW. And in this study, the corrected reflectance R lambda is found the acquired image SI0 using this equation. For the white reference, we use the Teflon whiteboard with a 99% reflectance, and for the dark, we recorded by turning off the lighting source. After that, the average PC is often by selecting PC from the BIS PC1 and the NIR and averaging them, we obtain the average PC principal component. After that, thresholding method is used to convert a grayscale image into a binary map so that objects can be segmented from the background image. The threshold is very sensitive, the segmentation processing. If the threshold is low, both the object regions and the significant amount of background can be degraded. In contrast, if the threshold is high, only a small subset of the region can be detected in our approach. So the best simple global thresholding is the OTSU method. We have used the OTSU method for the threshold passing. After passing through the global threshold, the pixel difference can be binary image, either 0 for a background, 0 for a background, and 1 for a foreground. Then the morphological operation with filter image to reduce and undesired nodes and to fill holes in the binary. After leveling of the fruit, the surface area is marked with the false colors, and we can identify the defected apples and the normal apple easily. The defected apples has the like a white image on the background color, so it will be easy to detect by the PC. These are the principal component elements. And second, in the proposed algorithm, PCA was used to differentiate the different defects from an apple from normal skin. According to the PCA, the mean and covariance of the hyperspectral image will be found, and image covariance is used to compute eigenvalue and eigenvector. As you can see, there are the eigenvalue bar projection of BIS, visual spectral region, and the near infrared region. From this figure, we can see that the PC component 1 has the higher range than the following 1 to 3 PC 1 to 10. So we use PC1 for our analysis. For the eigenvalue for BIS region, we use 403 nanometer to 695.7 nanometer, and for NIR region, we use 705 to 998 nanometers. These are the PC image in the all bands regions. PC1, PC2, and PC3 for the AV regions of the wavelength of 403 nanometer to 990 nanometer are shown in this figure. The defect like the bruise, which is not really visible in the original single band images, is more apparent in this transformed PCA image. These images have the same features like PCA1 image have light gray normal skin, black background, defects except bruise. Also, the boundary of normal skin and the background is clear. In comparison, the image of PC2 and the PC3 do not have a clear boundary among the normal skin. The background and the skin, the background and the defects, the PC2 have the light gray normal skin. It has a lighter normal skin and the background. The PC1 image have less noise on the normal scale around the defects, but the image PC2 and PC3 have a lot of noise on the normal scale and around the defects, as you can see in the figure. And the these are the results of the PC image in the BIS visual spectral region. The first three images of PC1 and PC2, PC3 of BIS is a wavelength from 403 nanometer to 695.7 are shown in this figure. Generally, the BIS region spectra images are little darker than the NIR region spectral image, especially the PC2 image of the BIS regions are much darker, so you can identify the noise on the normal skin and around the defect. And the first three images of the PC1, PC2 have the same noise on the normal skin and around the defect. And these are the PC images around the NIR region. The first three images of PC1, PC wavelength from 701 nanometer to 998 nanometer as shown in the figure. Generally, the NIR region spectra images are light brighter than the BIS region spectra, especially the PC2 images of the NIR are much brighter, as you can see in the figure. But now, after taking the results of all bands and NIR regions, BIS region, we find out the selection of average PC in BIS and as NIR region. The PC of the Apple image was carried out for three regions: AB, BIS, and NIR region. In selecting the PC image to build the proposed method, there are 6 options: only all band, only BIS, only NIR, or AB or BIS, or AB or NIR, or BIS or NIR, or all combined, AB, BIS, and average. But the evaluations of our method show that visual, spectral, and the near infrared are the best performance among them. So we carried out this performance for our method. The reason behind this was the best performance because the reflectance of the defects in the BIS region is more sensitive than that in the NIR region, like the crack and the cord. Namely, the size and the color of those defects in the BIS region are larger, darker than that in the NIR region. In contrast, the reflectance of the normal in the NIR region is more sensitive than of the BIS region. So we find out that the selection of average PC in BIS NIR region is the best for our method. Detection results of defective Apple sample figure shows that the detection each skin type using the proposed. The illustrated 4 defects types were randomly chosen from our 350 data set. The first row shows the original apples using HSI image, and the second row shows the PC1 BIS image, and the third and the fourth shows the PC1 NIR image, and the average PC generated from the BIS and NIR images. And the fifth row is binary images, which is represented by the DD. And these are the results which we have got from our evaluation and discussion. The Apple detection accuracy of defective emails and normal scale were proposed using 350 independent data set. As you can see, 85 were scabbed, 55 were bruised, 75 were cracked, 70 were cut, and 65 were normal. Among them, average PC1 from 2 regions, BIS and NIR, has the best accuracy among all of them, 94.28. And the average and the second highest is from the 3 regions, AB, BIS, and the NIR, which is 92.00. And the third highest is from the optimal band, 729.3 nanometer. This is the optimal band of our wavelength, which has the accuracy of 88.00%, and the all band PC1 has 85.71%, NIR has 86.85%, and the BIS has only 83.45%. So this all table shows that the method we have chosen from 2 regions, visual spectral and the near infrared region, got the best accuracy among them. So we have defined this method on our paper. So how we find the optimal wavelength? As you can see in this figure, this wavelength as the highest range in this year between the 700 and 750. As going back to the slide, as I have already mentioned here, optimal band is 729.3 band. So the range between this highest frequency lies between the 700 and 750, which is around 729 band. So this is the optimal band which we have used in our paper. And this is the hyperspectral data analysis from the visual spectral image, and this is the from NIR spectral image. At last, in this study, a method to classify apples into normal ones are using hyperation was proposed. The hyperespaces bandwidth was divided into three regions: BIS, NIR, and AV. The reflectance of each region was analyzed. PCA for each region was carried out. Finally, apple classifying method based on average PC was designed and evaluated. The results showed a PC1 image 94.28% overall detection rate using 150 independent samples with different skin conditions, which it proposed automated defect algorithm as effective. The proposed method is simple because it does not need Apple orientation and Apple image masking. I have already mentioned on the introduction side. The spectral region between is 402 nanometer and 998 nanometer was the most appropriate for the detection. As also we found the PCM method is better for the defect detection when compared with other bands. And these are the future words which we are going to conduct with the help of this paper. Steve and Calix defect detection, implementation defect fruits inspection of Apple industry, known and unknown defect detection. With this, I'd like to conclude my presentation. Thank you. Any questions?
Thank you for the presenter 42. And so may I ask you, do you have any questions to him?
May I?
Yeah, sure. You can.
I think it's a pretty good presentation and pretty good work as well. I have gone through with your paper.
Yes, thank you
I'm
very
only
much.
curious about one thing. Have you ever you didn't do any comparative analysis with some old research which is related with the same? Like there are many people who have done with the image processing or uh, even in factory also they are using some application already with to check the defect in fruit, vegetable, and all other one, even in the live animal also. So have you done any analysis with the existing application or existing?
No, we just find out the new method. We didn't apply on the existing method. We just created our new method by using a HSI image and the just PCA everything. Just we created a new one. We don't use it. We don't use our existing method.
Okay. No,
Any
what I
questions,
want to say, did you check any other existing work related with the
Yeah,
detection?
you can see in our paper there are lots of reference. We have read that papers and find out some solution, and I think from that paper this is the optimal one, best solutions to find the defect of the apple.
Okay. Okay, I understand. Point wise, I was thinking as did you do comparison with that one, like with the existing result which we have
Okay, I
received?
am helping with this way because I am also the co-author with this paper. Actually,
Oh, sure.
thank you very much. The idea.
Mm.
Actually, it's the conference paper, so we are not to added this part of this comparisons with the details. So we are
Ah,
just classified with the analysis of the data, and that databases we shown the results. In the futures, we have to definitely comparisons to add it the existing one, and we have to there is a also is the problem with this because the data sets. So if we have a change the data sets, parameters will not exist. So whatever that we are getting here in the optimal band, so the single band, so it might be is not the banana case or the other fruits because that
yeah.
depends on the shape, size, and the textures. So
True.
that's the reason. Thank you for your questions.
Yeah, no, that's pretty good. I think that for future work, I think it can also lead to a very good journal paper. So that's what I was
Definitely.
suggesting. That's pretty good work.
Thank you, sir. Thank you.
Thank you for it.
So, ma'am, do you have any question, Professor? No. Okay.
If I say out, it will be different thing. So totally different. So it's okay.
Okay.
I also agree with that.
So thank you for the presenters, and there is a
Thank you.
participant and the guest, and so there we have two more papers in left to the presentations. I think there is we have a define with the time, so maybe that author will come on time. So there is another paper, so that will be also in the Kyongdong University. That should be I will be present. So the paper ID is the 41. So during this time, I think I will be present.
Sure.
So
Hold on, I will leave here and have a good time, sir.
Thank you very much. Or you can continue.
Yeah, yeah.
Okay.
Yeah. We count just now like we have 4 paper already presented. So we
Yeah,
have one paper to go, right?
we have no 2 papers, 2 more papers.
Yeah, 2 more papers, right? 6 papers. But I don't see they are in.
So, okay, then let me present my ones. So,
Okay.
I have to. Rakesh, hello.
Yes, professor. Yes, professor.
I think there is a little bit in the wrong. So can you right click your the status, the remove the host? So the right click because I have a maybe wrongly select the host. Okay. Right click on the paper ID, presenter ID. There is a click and the make withdrawal in the host. Can you do that?
It's not showing, professor.
Oh, somebody come in.
Okay, professor, I make you host.
Oh, okay.
Yeah.
So you can, yeah, thank you. So yeah, someone is the co-author with this paper.
Mhm.
The Isanullah. So okay, so thank you for the honorable judges and the participants, and very good morning. So this is the conference, the Smart Cyber 2020. The paper title is the Deep Learning Based Apple Defect Detections with the R Squeeze Net. So here is we are the 3 authors. So the 2 affiliations universities, 2 are in our Kyangdong University, 1 is the DGEST. So uh, so now this is the outline of the paper. So there is the introductions, the related work, the experimental setup and implementations, performance simulations, and conclusions, the future works. So let me, I have introduced here the introduction, the motivations and objectives. So the recently in the agriculture sectors, there is a most important, the one of part, the fruits, the detections or the grading system or the processing system. So there is a, we are the buyer. So suppose the consumers, the look at it, the healthy foods, the color, textures, and the size, shape that should be in the looking good. That way is the fruits industry is doing in the processing. So in this Korea also there is a 23, more than 23 percentage the around the world the proceeding the apple fruits in the processing. So that's the objectives we are focused with the 3 areas because there is a nowadays is the challenging in the real time of applications. So in this case, so we are introducing here the introductions. So there is a apples, so there is a image acquisitions area, and there is a contributions. In the majority our contribution in the part 2, there is a applications and the contribution develop the algorithms, and there is a final thought, it should be in the approach real-time applications. So it would be in future we will be established to the real time of applications. The nowadays that we have a given survey of statistic, the industry, the fruits processing industry is not completed automated. The partial part is automated, partial is still now manual. So this, there is a sum of real-time problems. So that's the reasons we have to work with the interested with this work. So So now we have a given sum of for the why not the Apple defect detection. So there is a sum of limitations. Can you see in the left side with this one, the image, the when it is the industry processing, there is a the conveyor belt. There is a different industry followed by difference. The inline or there is a group or there is a the problem is the camera. So why it is need to the automations the human cannot to detect because the human have a exhausted and the neck eye the some focus will be lost, the accuracy will be reduced. That's the reasons the highly accuracies need to the industry and the processing fruits introduce the automation techniques. So in there is a image acquisition process, there is a fruits come to the viewpoint with the camera. So there is a still have a problem with the orientations. There is a how to orient it, the fruits coming through the which way the is the constants way, the it will be in the backside it will be problem or 360-degree with the viewing, because we don't know the randomly automatically we introducing this this idea should be in that the established in this area, it be the viewing system should be in the 360-degree the scanning object for the acquisition. And the second challenges is the huge challenges. I have introduced with the one, the references images. There is a the misclassified the steam part and there is a calyx part. So let me introduce in the bottom of the fruits, there is a we call in the calyx in the scientific name in the agriculture field, and there is a top of the hanging of the fruits, there is a steam part. So look at the right side, we have a distinguish with the two pictures. So look at it, there is a calyx, bottom the images. So there is a sum of spot that is with the different type of the diseases. So in look like his neck eye, it is that both are the same. So it will be sometime is the fruits are good, but it's the misclassified with this process. So we have to overcome with this one. This is the another challenging and look like see here is a sum of defect with the steam part. So final goal, it will be the automatic defect detection. So what are the proposed methods here? There is a input as a image, there is a the acquisition system and the processing with the techniques, the what we are proposed, and finally it make the decisions. Is there is a decisions, there is a if the negative, so it will be the defected, so it drop out the with the conveyor belt, and there is a and the next step will be the packaging the processing with the market. um, so now we are going with this one. Suggest I have a given the is the hyperspectral. So why it is the difference between the normal image and hyperspectral images? So as it is says in the in some of our students, so is mentioned hyperspectral the spectral basis provide the images. It is a not a single image. It is a multi images producing. So why it is the multi the if we normal camera took the one view, but at a time the complete regions they are scanning to the spectral regions, the producing the number of images, there we can easily to identify which is the more better than the next step the processing for the image. So it will be we have a good number of the input images, and the easily we can if we have a miss, so we have a go through in the details. So that is the overall view of the different visibilities with the among the web bands. There is a gap because there is a 400 to 1000. There is a gap between the 400 point seven. It is the nanometer will be gap to the pictures with the that is the difference on the camera. So we are the VCC the model camera. This camera have a this much gap. Some different type of the camera, it will be the reducing in the gap between wave bands. So I have a conceptual view with the given the some hyperspectral images. There is a four reason of interest shown to represent the images. One is the steam part, one is a defect part, one is a normal skin, and one is the background. So look at in the our spectral. There is a we have a mention there is a range of the spectral and there is a pixel so ratio. So look at in the bottom part with the background. So background is the bottom part and the high spectral represented with that graph with the top positions is a normal screens, and there is a two things. Look at is there is a pink color and the purple colors. So there is a as we said in there is a two reasons. There is a visual part and the near infrared. Look at the around the 700 the nanometers. So in between, look at it here in this two distinguish. So pink color is a defect. Defect one represent in the visual inspector is a good things. Okay, and there is a opposite. When it is the NRI part, it shown to the bottom of part. There is a spectral will be oppositely changes. So it is the very difficult to distinguish the class. So in the traditional techniques. So that's the reasons we are come to through with the our proposed methods, the deep learning basis that misclassified to the solve this problem. So there is another technique. So the how the image acquisitions, the still the around the world, the existing, there is a three categorized in the scanning system with the hyperspectral imaging. So one is the point basis, the is a scanning system, the pixel basis. So it will be more delay to take time. So it's one which is the processing with the time delay times. It's mere around 15 minutes is take the one image is scanning. So it's not suitable for the industry proposals. So area is also problem. If it is the orientation is not smart, like is a 360-degree, that will be another problem. And these images we have to take it the like this plarisms, and there is a overcome with this is technique. So we propose in the our method, it is the line scaling is the good. So is the spectral wise in the line to line, it's the image complete the sense. It will take in the around 300 spectral line is the given the informations with the images. So those were the technique for the image acquisitions, and this is the proposed methods to the how to yield the real work in the future. So this is the conveyor belt is the left, the right side, the moving the load with the images towards the view of camera. So there is a this wheel is the rotated, so fruits are coming through by, look at there is a steam part here. So is the next is the bottom, and there is a close opposite. So is the rotated is still now is the challenge is not 360-degree is the rotating. So is the partially rotated, but it is the in features it will be improvements needs. So there is a camera, and is there is a lighting setups needs to the hyperspectral images. Two halogen lights is to the 45-degree angles to the view reflecting with the objects, and the camera in the standalone system is the 45 centimeters. If it is the fruits object, so it should be adjustment with the camera settings. Otherwise it is not work with the others data sets or others object detections with the spectrals. And the right side with the given the moving belt, and during this time in the our algorithm will be satisfied and the give the decisions. And there is another part will be extended hardware need to the extended the signal passing the control system. If there is a fruits is the defected found, the signal will be the push the fruits and drop out the conveyor belts, and the good ones to go through with the for the next processing step. So now we are come to the in the our introduction in the general architectures. So the research content, so the overview of the our processing, how do we do this the problem. The number one, the hyperspectral the acquisition image, the our input processes, and there is a problem definitions. Already we talked with this related the improve we need to the defect detections, the accuracy in a spectral regions, because there is a hyper visual to the NRI part, and there is a misclassified with the steam and discriminations. There is a automatic defect detections and the approach of the real-time applications. Those were the problem definitions. The image acquisitions also need to the lighting condition is essential. If there is a problem with the lighting, so our the problem with the scanning input data, and the results will be given the negative. So is there is also the conditions will be the established, the setup of the studio, how to will be the setup. It is the different environment, it might be in the different. So that was also the challenging, and also the scanning and the fruits orientation is most important, because the fruits we need to the 360-degree scanning system. And speed also need to the, because if it is the slow processing, the industry will be is not to like this system. That are the image acquisition, the preparing data sets. We have here the preparations with the data sets. Here we using in the 8 classes. So that classes we have to present the output will get the results in the separately. The defected, there is a many kind of defected, but in these data sets we have only the 6 classes, and the normal also they have the classes, the normal and the steam and the classes, because there is a steam and class also the misclassified with this one. The pre-processing, there is a, we need to the image corrections, and we are using for the deep learning data sets using the pass, using the slide. So how do we make in the pass the sliding windows, the techniques, and the spectral analysis, the all the spectral 3 regions analysis, and the case of the was, which is the best wavelengths, and there is the effective, we select the wavebands, and that basis we have to the finally we go our the algorithm processing and analysis. There is a 2 techniques we are introducing here, the deep learning approach, the squeeze net architectures, and also the we are not shown in the comparisons in this here. In futures we added the AlexNet and the GoogleNet to the comparing with the results, but in this paper we have a lackings, we are not to add it for this one. And the squeeze net architecture utilized, there is a convolution neural network, the popular techniques for the deep learnings, and also there is another fire module, the bypass the connections between the fire modules and across the images. Those who are the content we are to processing this one. So nowadays we have to related work. So the lot of research has been the carried out in the apple defect detections and the fruit grading in a hyperspectral imaging over the year. The especially this sector, the fruits processing in the past work the traditional image processing technique. So recently some of few papers will be start with the deep learning techniques, and these techniques will be also the implemented, the real time application is the tough. So that's the reasons. So we have a work with this one. We provide in the overview in the work done in the different type of the apples defects classification work, and shown the research work in the evaluating in the challenging area. The proposed system with the comparisons with the state of arts method based in the deep convolution neural network and the image classification accuracy. We have the followed with the sum of state of art methods during this processing. So now we have a main algorithm we started here. So we have introducing the network architectures design is the strategies. What are the strategies? The object in this work was in the identify CNN architectures that have a few parameters while the maintaining the competitive accuracy. As if this we employ the 3 main stages. What are the benefit stage? Stage 1. So normally the convolution neural network, the 3 by 3 filters using, so it's replaced the reducing the parameters. That is the advantage of the 1 by 1 filter we are using. Since 1 by 1 filter has a 9 fewer the parameters than the 3 by 3 filters. And the strategy 2 in the decrease the number of input channels to 3 by 3 filters. So and also the strategy 3 in the downsample rate in the network in the convolutions layer in the architectures and maps. So here we have a given the fire model. So right side look at the pictures, there is a squeeze. So it is the 1 by 1 the convolutions filter, and the expanded there is a mix, there is a 1 by 1 and the 3 3 and Rulu. In the fire module, how to exist the fire module is the compared of the squeeze the convolutions layer which is the only 1 by 1 filter, and the feeding into the expand layer with has a mix of 1 by 1 and the 3 convolution filter, and Libra use the 1 by 1 filter in the fire module in a application the strategy 1. So there is a squeeze 1 by 1, the number of filter, the squeeze layer is all 1 by 1. So the expand 1 by 1, there is a number of 1 by 1 filter expanded layer, and the expand 3 by 3 numbers of layer. Look at the 3 by 3 is a 9 filter is expanded layer. When with the fire module, we set the S 1 by 1 to less than and this one. So the squeeze layer is a help to the limit number of input channels with the 3 by 3 filters, and is the satisfied with the previous slide is the strategy with the 2. Now we have a given here is a our the network architecture. So what is that? There is a input. There is a 2 to 7 by 2 to 7. That it is a standard architectures for the SqueezeNet input images. That input images patches we have provided here, and there is a convolution starting with the layer is the convolutions one, and there is a we picked up here is the maximum pool and the fire module to the exist 2 to there is a 9 fire modules 2 to 9, and there is a finally we come with that the convolutions layers, and that we picked up with the softmax, the classifications, the average pooling, and also the detections. The finally we have to get the detection with the apple. So let's me I go through with this one. The these are the description we have mentioned with the left side with the text, the whatever we have followed with the, and there is a structures, there is a channels will be customized the parameters. So it will be the we have a based on our architectures, we choose this number of parameters channels we have uses for our network. So now we are going for the residual squeeze net architectures. There is a also the some of existing look at, there is a two similarities with this the squeeze net architectures, and there is a residual squeeze net architectures. Here it is a the bypass, so it will be like this. So the same thing, but here is a the two thing is advantage. Here will be the stage. The previous case, if we look at, there is a what are the features getting in the fire module 3, that should be in the come to the processing with the fire module 4. But here here is a advantage. So there is a is coming from the fire module, what is the input that directly is given features from the pre-processing with the fire module 4, and there is a processing with the fire module 3. The together there is a we getting in the more features in the next fire modules to in the processing, and the accuracy will be more higher than that the squeeze net. So this is the distinguish with the residual and the squeeze net network architecture. So in this, the Luru in applied to activities from the squeeze and the expanded layer, and the dropout with the a ratio of 50% to avoid to avoid our the overfit. And also lack in this architectures, the lacking with the fully connected layer in architecture. So because we need to the fast processing, so we ignore for this one the fully connected layers, and that's the reasons our proposed method here is a residual squeeze net architecture. So learning rate is the equals to 0.01 to then the setup size is a 10, and the SGD in the we have to optimization for the our the accuracy results. So now we have a data preparations. There is a labeling of image crop of the classification, use the two folds, the cross validation accuracy for the evaluations. The final list are the written into the into text file with the absolute image path, and the class level separated by a white space, and the class level in number of separate level. Text file is used to the map for the number of to the class names. So now we are going to the discussion about our results. So the in the table represented here, so the training the squeeze net and the residual squeeze net model. So there is a we are using in our data sets own creations, our the data sets on sources data 9,000 the data, and there is a contained with the 8 classes, and there is a 30 ECOPS, and the validation model with the 180 1,800 samples will contain in all 8 classes. So the squeezeness results is given. There is a two class that we have a make it in the whole images to also produce the processing entire the apple images. We have to shown in the beginning slides the whole image we provide, we are getting in the less results with the both the cases. And there is a when we have a given the pass, that pass will be the we are getting with the more accurate the results. So we have a given the less number of patches. There is a size of the 64 by 64 given the patches size, and this is the we are getting the results. So there is a also the distinguish with the two difference. So when we have a using the ordinary the squeeze net, the result is less. And when it is we using the both the firewall modules and the bypass, so it will be results network is the 0.26 is the increase over the results. And finally, we have a given the cross validations with the data, so it will be in the given in the two folds, in make it in the two-fold equally, and there is a we given the results. Also in this case also we are finding in the results in our with the classes for this the less than for the squeeze net, and results is the best. That's our proposed methods to the this technique will be in the good for that, and the time consuming in the for these solutions. So let me conclude. In our conclusion, our contributions, the two words: first, we create the large scale in the data set Apple defect recognition with the number of images and with the eye difference. And secondly, we propose the investigation, the unexplored. The approach is a highly robustness and real-time automated. And this method we are the, actually approaching to the become a real-time. So it not implemented. And the two words in the goal of have a presence in the deep neural network and CNN architectures has look at there is the 53 in the fewer than the parameters, the AlexNet. So Google Net also is the similar. So we have to futures work we have to do in the comparisons. So the with the squeeze nets techniques. So now we are going to in the futures work. So look like this left side is fruits really is looking good. So we don't know what happened in the inside. So inside is the molten in the sum of defected. So normally what we used to do in the outside in doing the skin, the surface area we are defecting. So we need to the future work the in inspections with the entire the fruits, because we have to better quality provide to the consumers. So it is the one of samples I have to shows to here. So we need to the future work inside the whole inspections with the images. See this one, we cannot. So the same sample, we have to cut it and show the represented. There is a fungal and montal diseases is not eatable to in the healthy foods in the processing industry. So this is the third one. So we have to in futures work, we have to do the more accuracy to increase and the comparisons with the others networks and the establish real-time fruits processing applications, not to approaching. Thank you very much for the my presentations. If there you have a questions, please.
Okay, we actually have more than 20 minutes.
Yeah.
Yeah,
So
I think we don't have enough time for asking
okay.
some more questions,
Okay.
because the last presenter, she had to start, actually she had to finish earlier. So we had to continue for the
Yeah,
last
okay, sure.
presenter.
Okay.
Yeah.
Thank you very much. So now the paper ID will be, okay, let's me stop the my sharing.
Let's see, now we have the Manjula
No,
and
Manjula already done.
okay, so it's Ilsan Ula.
Esanullah is the co-author with the last presenting paper.
Yeah. So can you change your name to your presenter number?
Esanullah, please you change the right click on the rename. The paper ID is the 41. Presenter ID is 41.
Okay, sure. I will do that. Okay now?
Yeah. Not 42, 41.
Oh, sorry. I'm sorry. I will change it again.
So we have to, Professor, we have to wait because the last presenter is not yet to come. The paper ID is, presenter ID is 52.
Okay. So the presenter 41 is?
with me in the, he's the currently doing in the doctorate program, Daegu, the GIST.
I see. So just now the presenter 41 is not the presenter for the last presenter?
Yeah, last presenter, he's a co-author, he's not presenter. I was the presenter.
I see. So now we have to wait for the last person?
Yeah, because we have given the time, so until 20 minutes, let's see in the 12, we can close our sessions. 10 more minutes, we have to wait for them.
Yeah. Actually, your title is very interesting, actually, for me.
yeah, it's really. Thank you for. Actually, we started from this work in the PhD level. So my professors was given, there is a, we are same, Esanullah and me, we are the same university. During that time, he was in master's students. So there is a RDA, they producing the, access the lab to the image acquisitions.
I see, because like today topic is very similar to my research too. Even I in the electrical department, so my research more to the image processing. So today about the phase image processing and PCA algorithm. So this is what I apply already inside my research. So that's why like I can like for a neural network, it's like very common method that I used last time. So it's something like very interesting for me. So it's something like I did it before, and then they have more like they add on more things inside there, but I can't see the results so well, especially for the face reconnections. So this
phase is really challenging, ma'am, because there is a pause, there is a lot of parameters to detections to that.
Yeah, because my PhD is with the face reconnection. So when I ask her the questions, I also feel so sorry with that. But this is a very common question they're going to ask because like, by the sadness, you know, or like happy, that kind of topic you already have already 10 years ago. So, so when I see that she go through all the process, so a little bit like, maybe it can give some suggestion or something like that. So, but she's still in the progress of doing that. Just to keep silent. Yeah. But Apple detection, I think is quite interesting because like Apple in the industry is quite big in Korea too. Yeah.
So mainly we face in the problem, the hardware. So there is the some of industry doing in the manual processing, wash part, the detecting in the human, only the packing or there is the, so we have to integrate it all the work. The mainly challenge is the acquisitions. If we change our setups and also lighting conditions, and the main is the fruit orientation. Fruits become a look like in the, it's not to, if there is a backside in something in the skin, so we are not getting in the results. So we have to better to, and also we need to the MRI or some related to the camera inside to need to the inspections. So I show in that in the last slides, so that things are the really challenges. The classification,
so maybe, classification would be nice because like I don't think you need a lot of classifications. Like as long as they have to find each defect and not defect, right?
Yeah, we don't know. But there is if we go for grading, ma'am, then we will know the size, shape, and textures. People will look in the nice one textures. The is green, lovely, is red, delicious. So that basis we have a make the set the parameters to the classification. Normally defect case no need. Defect means all are defect. So 2 class we need.
I think maybe also they can. I don't think a lot of like that kind of Apple factories they want to put a lot of money in in the classification and investigation. So if they put more money there, I think like just now just now the conveyor they want to move the Apple. Still put another, it's like conveyor like nowadays they have a lot of new conveyor outs. Like it's not like that kind of conveyor. It's the conveyor that just with a shaft. That's why the apple at the top and the down.
Yeah,
there.
they have a hardware, the bases, the diameter, the setup, and they have to, okay, they're circling with this one, okay, big one, the pass. If it is a small one, like that way, they're throwing to the hardware bases they're doing in that. The
so they had that kind of conveyor. It's like they don't invest a lot of money with the conveyor. It's like
and also, Professor, there is a test. The color is okay, but taste is different. So that should be in the more complicated to the processing or grading. So that need to some chemical tested also. So we can the taste will be the different. And if you have a fresh, that is really tested. If it is some long time to refrigerating, or there is something to the prevented, it will be the change that, and also the skin.
There's a lot of challenge each they want to go through. Yeah, that's true. So that's why just now I see the one camera at the top. It's like they don't want to invest money to save it. The other one camera at the bottom. Actually, when they go through the process, it will be okay. At least like 180 degrees instead of 360. Yeah, but normally they don't spend that kind of money for two cameras. That's the point. Yeah, I think it's very challenging too. Yeah. I think it's not that challenging from the image, like face recognitions, but also quite challenging because like Apple, you think about, because you don't process in 3D. So image you can, I think face you can process in 3D, 4D. So so many things to go through. Yes. Yeah. I think that's the thing. It's very important, interesting subject. Yeah. I think.
Isanullah, if you want to share your research, you can share. So just talking is okay.
Actually, I was thinking about. Hello, everyone. Actually, I'm Isanullah, and I'm from DGIS, Daegu Gyeongbuk Institute of Science and Technology, and I'm doing PhD in here. And my research is mostly related to deep learning, which I studied with Noor Alam in Chunbuk National University, Professor Noor Alam. I was doing my master's, and at that time I was doing deep learning, and I was applying it for vehicles recognition. But now my research is a little bit changed, and it's towards like medical imaging mostly, and I'm working with robots. So because right now I'm in robotics department. So I'm trying to find out like catheters and X-ray in the human body, that where it is and how we have to reach it to its targeted area and find the optimal path for that. Yeah, actually like I work with some of the project related to face in my master's too. So the thing is, like if we compare about the Apple research and the face research, I think there's like a lot of contribution made to the face recognitions, because there's like the main problem with the deep learning or CNN, it's like the data. So in face recognition, we have like a lot of faces databases available online, but with the Apple's, these data sets are not available online on the websites, or maybe you can say it's not public data sets. So it's like kind of we call it like messy data, or maybe like there is too much like kind of like real applications for that. So it's quite difficult in the Apple cases, but in the face cases, I think it's like there is a lot of databases, so we can train really good models which can give really high accuracy. But so far, like when I was reading papers regarding face ID recognitions, so sometimes we call this CNN is kind of racist, because it doesn't work mostly on the black people. I don't know why, but there was like one article I read about it, and that said like the black people face feature is quite similar, so it's quite hard to work on that. So it's mostly work on the people like how to say, which is like European or English people. Yeah, but the Chinese and I mean these Asian people like Chinese, Koreans, their face expressions are features are and the black people features are quite similar, but the other people's, I mean, European or maybe like other part of the people who look like Caucasians, the model works better on their faces. So yeah, that's one of the issues. There was like a paper related to that which I read, so I just wanted to add that information in here. And yeah, so thank you. And if you have any question, actually I work with this Apple classification method, and I implemented this Alex, SqueezeNet and residual SqueezeNet. So if you have any